This I'm Stark, and in this video we are looking at integrating rational functions. So by resolving a rational function into partial fractions, each part is a standard integral and can be integrated. So this is also known as integrating partial fractions. So our first step is to resolve into partial fractions. So therefore we have here integrate 4x minus 2 over x plus 4 x minus 2. So therefore this is just using our simple knowledge of partial fractions. So this is going to be equal to a over x plus 4 and then plus b over x minus 2. And if you don't know how to do partial fractions, I will go through it briefly in this video. However, if you want a fully explained video, look on my partial fractions video. But then what we're going to do is times it by the bottom. So that means that what we have is 4x minus 2. That's going to be equal to a times by x minus 2 plus b x plus 4. Then we have to cancel the a and the b, so we will let x equal 2, because that will make it 2 minus 2, which means that there will be no a, and that will say that 8 minus 2, 6, is going to be equal to 2 plus 4, 6b. So 6 is equal to 6b, therefore b is equal to 1. Then we can let x equal minus 4, and that will get rid of b. So therefore what we have here is 4 times by minus 4, minus 16, minus 2, minus 18 is equal to minus 4 minus 2, minus 6a. That means that we know that a is equal to 3. So now we have our partial fractions, and we can now say that we are integrating 3 over x plus 4 plus 1 over x minus 2. So we know that 1 over x is equal to ln x if you integrate it. So 1 over x integrated is ln x. So therefore we can use this to make this all ln. So for the first one, that is going to integrate to 3 ln and then x plus 4. The second one, 1 over x minus 2, is just going to integrate to give ln x minus 2. And then instead of just putting a c, we're going to put it ln k, as that is a constant in this term. Now we could do a little bit of rearranging here. So using our third logarithm rule, we're going to make this ln x plus 4 cubed. Then it's going to be plus ln x minus 2 then plus ln k. And for our final step, we can make it all in terms of ln. So we have a ln here, then the k, and then this is going to be as it's added together, it means that everything is going to be times together. So that means that we have x plus 4 cubed, and that is going to be times by x minus 2. And that is how you express your final answer. So the next question we have is fairly similar, but just with slightly more difficult numbers. So again, we can say that this is going to be equal to a over 2x plus 3 plus b over x minus 1. Then again, what we do is we times everything by the denominator. So we're left with 2x plus 1 is going to be equal to a times by x minus 1 plus b 2x plus 3. So therefore, in order to get rid of this a, we can let x equal 1. So that means that we're going to say that 3 is equal to 5b. Therefore, b is equal to 3/5. Then if we let x equal minus 1.5 to get rid of that, then what we're going to get is minus 2 is equal to minus 5 over 2a. When using a calculator, you're able to find that a is equal to 4/5. So therefore now what we're doing is we are integrating 4/5 over 2x plus 3. This could be written as 4 over 5 times the 2x plus 3, but just putting it in this way makes it slightly easier when we come to integrate it. And then that will be plus 3/5 over, and then this time it will be x minus 1. So that, therefore, is going to be equal. So this is going to be 2/5 ln 2x plus 3. Now, the reason it is 2/5 and not 4/5 is because we have this 2 here above in front of the x. It means that it's going to have to divide it by 2. So that is what we have to do if there is a 2 and it's these exponential functions. It's like you do in something like trigonometric integration. You do have to divide it by that. So that is why we have had to do that in that case, and it's not 4/5. So that's going to be 2x plus 3. Then that will be plus, this will stay as 3/5 because it is just x. So 3/5 and then ln x minus 1. And then finally we have that ln k. So therefore, what we're going to have as our final answer is ln, then we'll have the k here, then we've got the 2x plus 3, and then that will be to the power of 2/5. That will be times by x minus 1 to the power of 3/5. So therefore, that is our final answer. So the final question that we're looking at today involves limits. But to start off, we're going to make this exactly the same as we have done in the previous questions and resolve it into partial fractions. So this time, we're going to say that this is going to be equal to a over x minus 3, then plus b over x minus 1. Therefore, again, times everything by the denominator, we're just going to get 2 is equal to a x minus 1 plus b x minus 3. Therefore, let x equal 1, and we're going to get 2 is equal to minus 2b. So therefore, b is equal to minus 1. And then x is equal, therefore, to 3. That means that 2 is equal to 2a. And that means that a is equal to 1. So now what we have is integrating 1 over x minus 3 minus 1 over x minus 1. So that is therefore going to be equal to ln x minus 3 minus ln x minus 1. And then we don't need a limit, we don't need a k, sorry, because we have limits in here. So that means that because it's minus and using the second law of logarithms, this is going to go to ln and then x minus 3 over x minus 1. And then this is all going to be put into the larger limits of 5 and 4. So that means that we're going to put those in, and that will leave us with ln of a half minus ln of a third. That would be the same as ln of a half divided by ln of a third, which is equal to ln of 3 over 2. And there we are. That is our final answer. So that's just a new dimension of using limits, along with this idea of partial fractions and how to integrate them. So thank you for watching this video, and see you soon. Bye.